Okay, stats. We're on day 6. Three of these days left, I guess. We're doing chapter 7 stuff today, which is all about confidence intervals. Okay, so just to kind of refresh your brain, this is the formulas that we have for confidence intervals, and there are proportions, mean, variance, and standard deviation. Okay, now just down below here I have 3 problems for you to do. 45, 46, 47. I do not give you a confidence interval for variance, okay? So you can cross it off if you want to. Variance and standard deviation are very similar to each other, except for that you take the square root of each side, I guess in the square root of the middle too, to get your standard deviation, right? Standard deviation is the square root of the variance. So I don't actually give you a variance problem because they're basically the same formula. I'm just going to make you do one of those, so we do standard deviation instead of variance, okay? I'm going to kind of walk you through like how to do proportion, because that one's the ickiest one, and we'll talk about how to get that stuff, and then mean and standard deviation should be fairly short and sweet from there. But what you're trying to solve for and what you're trying to find is the interval right here. Like, this is the ultimate goal right here, okay? So I'm just going to make up some stuff. So this is made up information. Made up information. Don't use this for anything. Let's say that 8 out of 14 students in the class like chocolate ice cream. I don't know. Maybe 8 out of 14, your favorite kind of ice cream is chocolate ice cream. Maybe the rest of you like vanilla or some other yucky kind. Chocolate is the best. So this number should actually be higher. You people who don't like chocolate ice cream, boo on you. 8 out of 14. 8 out of 14 gives me, for a percentage, we call this p hat. Our p hat value, 8 divided by 14, is 57% and change. So we'll just go 0.57. P hat in this case would be 0.57. That is the number of people who like chocolate ice cream percentage. Q hat is going to be the opposite of that, okay? So if I subtract that from 100%, that would be like 0.43, okay? These two have to add up to be 100%, right? P hat and Q hat, all right? Now, it is not fair for me to say that even though you guys' class, 57% likes chocolate ice cream, it wouldn't be fair for me to advertise that 57% of all seniors everywhere like chocolate ice cream, or even in the whole town of Blue Hill, all 57% of seniors, because we're not including all of the seniors. We're only including 14 of you, and there's more seniors than that. We wouldn't say 57% definitively. We would say somewhere between this number and this number like chocolate ice cream, okay? And we do that by calculating the error, okay? And the error a lot of times is based on how big our n is. So the bigger your n is, the smaller your error. We are only surveying 14 students, which is not a lot. So our error is likely to be pretty high in this case, okay? So, and we're going to see that here at the end, okay? So what we need to do is calculate the error, add and subtract it from p hat, and that will give me a range of values, right? So instead I would say somewhere between this many and this many percent of seniors like chocolate ice cream, okay? Instead of saying exactly 57%, and that's how that works, okay? All right, so here's the deal. We have kind of like 4 parts to this. If we keep going with my chocolate ice cream example, we have the z value, and they have z of alpha over 2. The alpha over 2 doesn't really mean a whole lot. It's just like the z value. P hat and Q hat and n. Okay, n we said was 14. We surveyed 14 people. P hat was 0.57, Q hat was 0.43, and then we need to figure out what Z is, okay? So they have to tell me what percent confidence, okay? 95% confidence. That kind of like corresponds to a fish value of 0.05, right? So sometimes they'll write it like my fish value, and sometimes they'll write it as 95%. Those mean the same thing, okay? But when we're doing a proportion, we're looking at the Z chart, okay, Z chart. So I'm going to go up here to the Z chart. This is positive Z scores, okay? And I'm going to go to, oh shoot, I don't have it. I cut it off at the end. Ah, crap. 95% is like either 1.96 or 1.645. Let me find it. Nope, right here. Right here. Boop, boop, boop. Here we go. Here he is. 0.05 is a 95% confidence level. 1.96. Okay. I'm going to go back. 1.96 is the z value that I need. So I'm going to put that right here. And then I can use that to calculate my error. So 1.96 times all of that. And let me see what I get. And then we'll see what the error is. Times. Okay. And 6. And I get, holy crap, I get like a 26% error. 0.26 if I round to 2 decimal places. That's a big error. 26% error is huge. But again, that's because we only surveyed 14 people. So rather than saying exactly 57%, we would take 57%, we would add 26% and subtract 26%. If I subtract 26, that is like 31%. And if I add 26%, that would be like 83%. So that doesn't really narrow our window down a whole lot. We would say we are 95% confident that the proportion of seniors who prefer chocolate ice cream is between 31% and 83%. Okay, so again, that window isn't really narrowed down. 31 to 83%. Well, really great. That narrows it down. It doesn't, because we only surveyed 14 kids, right? Okay, but that's all we have to go off of for our data. So typically we'd want to do like maybe 50 kids, and then our window would be a lot smaller here. But for now, that's all we have to go off of, okay? All right, now, the only tricky thing for mean and standard deviation is that you're using a different chart. So you're using the t-chart, okay? T-chart is on the back side of the chi-squared chart. So these two are the same chart. One is on one side and one is on the other side. Your t-chart, you will need to know degrees of freedom on the left side, which is always 1 less than n, okay? So you take your n minus 1, and then on the top it should tell you what percentage you are. So 95% or 99% or whatever. The chi-squared chart, you will have 2 different numbers, okay? They will be your chi-squared right and your chi-squared left number, okay? And those 2 numbers go here, but they switch places. So the right one is on the left side of the equation. The left one is on the right side of the equation. And if you remember doing this when we did this in class, you put the right one here and the left one here, because when you're dividing by a bigger number, it's going to give you a smaller value. If you're dividing by a smaller number, it's going to give you a bigger value, okay? So that's why we crisscross those, and the right one goes on the left and the left one goes on the right, okay? Now, one big thing with the standard deviation and the chi-squared chart, when you get these numbers, you don't square them. A lot of people think this number needs to be squared again. No, chi-squared, this number is already just the number from the chart. So the number just goes in that spot, the number just goes in that spot. You don't have to square it then again. You do have to square the standard deviation up here on the top, but you don't have to square the bottom number, okay? It's already like the chi-squared value, okay, from the chart, okay? So you have to use a different chart for those, for mean and standard deviation. Hopefully that was okay for you. On 45, 46, and 47, you are using different things from that table. So we're talking about proportion of students that are older than 18 and a half, okay? Proportion of students that are older than 18 and a half. Let me go to my chart here. Older than 18 and a half. Let me get rid of some of this stuff, okay? So who is older than 18 and a half? Not this person. Older than 18 and a half. Not this person. Not this person. Older than 18 and a half. Nope, nope, nope. This person and this person. 18 and a half, 18 and a half, 18 and a half. Okay, so that many people. 1, 2, 3, 4, 5, 6 out of 14. Okay, that's what you're looking at for this information down here. 6 out of 14. 14 students for N. The number of, or the proportion of students older than 18 and a half is 6 out of 14, which is whatever percentage that goes here. That's your p-hat value, okay? That's what you're looking at for 45. Make sure that you explain what this confidence interval means in your own words, kind of like I did right here. What does that confidence interval mean? All right. 46, you are looking at the mean age of students. Okay, so you're going back to that same column, but you're going to use the average age, which is 18.4 for an average age. Okay, and then you're gonna make a confidence interval out of that one. Last one for standard deviation is going to be the standard deviation for the age, okay? So I think our standard deviation was like 0.5 or something like that. Go back to that column and make sure you write the standard deviation down right. But that'll be the confidence interval for that, okay? So you're looking at the same column, but different things about that column, all right? 45, 46, 47, there's your formulas, okay? Help each other out if you get stuck. There you go.